Bismillahirrahmanirrahim. Assalamu alaikum and hello to everyone. So in this lecture we are going to discuss about the concept behind isomerism and how how it can be categorized into different types. So starting, I'll say that organic chemistry is somehow extremely mysterious, right? So when you're studying organic chemistry, you will find like a millions of mysteries. You will go deeper and deeper. It will never end. So one of the mysteries of organic chemistry is isomerism, right? So how it is a mystery? Let's say I give you a formula, a molecular formula, in which what is a molecular formula in which number of atoms are shown. So I give you a molecular formula of this pentane C5H12. It is a simple hydrocarbon. And I ask you to write the structural formula of this compound. So what is structural formula in which the connectivities of bonds are shown? So you'll say that it can be N-pentane, right? It can be N-pentane. But it can also be isopentane in which one CH3 is as a substituent isopentane. But it can also be neopentane in which two methyl groups are connected as substituents. So with all these three structural formulas, the molecular formula, which is C5H12, is same, right? Is same. So similar, we'll say similar molecular formula. But where is the difference? The difference is that they have a different structural formula. Structural formula. So these three compounds, N-pentane, isopentane, and neopentane, they have similar molecular formula but different structural formula. So this phenomena is isomerism, and these compounds are isomers of each other. So we'll say that they are isomers of each other. So this is their relation in between. So to recall what we said is that if we write a molecular formula of a certain compound, we cannot estimate the structural formula. It can be different. Like in this case of pentane, we discussed three basic structural isomers where we said that this can be N-pentane, this can be isopentane, and this can be neopentane. So this phenomena is known as isomerism, and these compounds are called isomers. This definition of isomerism is taught at basic level, right, up till the 12th grade. However, if we move on to the higher level of studies like the bachelor's, there they will tell you that this concept of isomerism, it gets wider, right? Wider in a sense that they will tell you the basis of difference between the structural formulas. Like here, what we studied, one example is one specific type of isomerism where there is difference between the carbon skeleton of the compounds. However, there can be more criterias for the difference of structural formulas. So based on these differences, the compounds, the isomers, they can be categorized into different types. Mainly, this difference one can be differentiated on the basis of difference in their bond connectivity, whereas the second type is based on the difference in the arrangement of groups in space. So mainly, these isomers are this phenomena of isomerism, it can be further categorized into two main types. First one is the structural isomerism, and second one is the stereo isomerism. So, as indicated by the name, structural isomers are those in which there is a difference of structure. Now, that difference can be based on the difference of carbon skeleton. Like in general, we can say that there will be difference in the bond connectivities. So, apart from the difference of a carbon skeleton, they can be different in on the basis of the position of some substituents that are attached. They can be different on the basis of functional groups which are attached. So all of these types, they are categorized into one group, which is a structural isomerism, because their connectivity of bonds is somehow different. So there are different types of structural isomerism. We will just name them here and then we will discuss them in the second video. Structural isomerism or isomers. So it can be chain isomerism. In chain isomerism, there is a difference of the carbon skeleton. Second type of structural isomerism is position isomerism, in which there is difference of the position of substituents that are attached around a carbon skeleton, like 2-bromopentane and 3-bromopentane. They are positional isomers. The third type of structural isomerism is functional group isomerism, where there is difference of functional groups. Yes, we are discussing the names here because we'll discuss them in detail in the next video. So the functional group isomerism. The fourth type of this structural isomerism is metamerism, in which the arrangement of atom around a central atom is different. So arrangement of carbon atoms is different around a central atom is metamerism. And finally, the fifth type is tautomerism. Like you have heard the name of keto-enol tautomerism and like that. So these are the types of structural isomers. Moving on to the uh, second type, which is our second category of isomerism, which is stereoisomerism. So stereo means space. So in this type of isomerism, there will be no difference of connectivity of atoms. Like if you see the structure in 2D, in two-dimensional way, they will look exactly the same. However, they will be different on the basis of the arrangement of groups in space, like in three-dimensional space. So to understand the concept of stereoisomerism, you have to recall the concept of the tetrahedral nature of the uh, the carbon, which you must have learned basic in at basic level when you were studying sp3 hybridization. So let's say I have written this structure. This is cyclohexanol, 3-chlorocyclohexanol. Now in 2D, this the structure will be written like this. However, there can be certain uh, certain structures which can be posed based on the difference of the arrangement of these atoms. So as you know, for the tetrahedral structure of carbon, what will happen is that two groups, they will be in plane. One will be above the plane and one will be behind the plane. So this bond, this shows above the plane, and this dash bond it shows below the plane. So for stereoisomerism, you have to imagine this, okay, below the plane. So based on this, you will see that these carbons, all of these carbons are sp3 hybridized. So these carbons on which the groups are attached, they are also sp3 hybridized. So these two carbons of the ring, they are in space. So along with this, you know that 1, 2, and 3 bonds are there. So there is a fourth substituent which is a hydrogen, right? So two bonds of the ring are in plane, and the remaining two, they can be written as like this, that whether OH is above the plane, in that case hydrogen will be below the plane, and chlorine is above the plane and hydrogen will be below the plane. So this is a cis isomer, we call it cis isomer. We'll discuss that later. Secondly, we can write it as that for the case where one of the substituents will be above the plane and the other one is below the plane. So these two are stereoisomers of each other. If you see the structure in a two-dimensional space, which is written over here, the structure number 1, then these two will look exactly the same. However, you can write them as this, that this is the cis isomer and this is the trans isomer. So stereoisomerism is a phenomena where there will be difference of the arrangement of groups in space, whether like here the chlorine is above the plane and here the chlorine is below the plane. So this is the cis isomer and this is the trans isomer. However, the chlorine is attached to similar carbon in both, and the OH is also attached to similar carbon in both. So there is no difference in the connectivity of bonds. However, the difference is based on the arrangement of the groups in space. So this is known as stereoisomerism. So stereoisomers are also categorized into different types. The two main types of stereoisomers are geometrical geometrical isomers. So this example we discussed here, cis and trans, it is an example of geometrical isomerism. And there is another type of stereoisomerism which is known as conformational isomerism. So we'll discuss that later. Conformational isomers. So in today's lecture, what we have discussed is what is isomerism, what is the basic concept behind isomerism, and how it can be characterized into different types. So there are main two types of isomerism. First one is the structural isomerism, and second one is the stereoisomerism. And these two main groups, they are further can be divided into different types based on the differences in connectivity, or based on the difference of arrangement in space. So we have discussed a basic introduction about the types of structural isomerism and the types of stereo isomerism. So see you in next video.